So let me take a minute to go over an example with you and show you some other ways that we can use StatCrunch to find scatter plots as well as correlation coefficients. So what we're looking at here on the left-hand side of the screen is some data for male and female MRIs and their IQ scores. So the question was, researchers wanted to know, was there an association or some sort of correlation between your brain size and IQ scores? So it's an old study that was done, kind of a controversial study. And the data that we were given in StatCrunch or in the problem from your homework actually takes the MRI and IQ scores and subdivides it into male and female, so by gender. Now, the question that we want to answer is there a relationship in general between MRI and IQ scores? And the way that the data is given to us here in these subcategories is not going to allow us to make a scatter plot for just overall MRI versus IQ scores. So what do I need to do? Well, the first thing I'm going to do is I'm going to come over here and I am going to make a separate column for MRI and IQ scores. And in that, and I'm going to total up the MRIs, or I'm going to transfer the data over here underneath this MRI column. So for the female MRI information, I'm going to copy it to this new column, do the same for my male MRI values here. All of that's now going to go under the MRI column, and I'm going to do the same thing for IQ scores for female, IQ scores for male. So here I have MRI versus IQ scores, and I want to go in and create a scatter plot for that. So one of the ways that I can do that is to go under Graph, Scatter Plot, select the column for my MRIs as well as the column for my IQ scores, and I'm just going to hit Compute. So here I have a scatter plot representing this data that now takes not subdividing it by gender, but now combining it to just in general, here's the data for MRI versus IQ scores. And if I wanted to know whether or not there is a relationship between them, where MRI was treated as the input variable, IQ is treated as the output variable, what's the correlation coefficient for this? Well, one other way, so I showed you in class, one of the ways to do that was to go down to regression, simple linear, and I can not only find the scatter plot, but I could also find the correlation coefficient. So what I want to show you here is another way that's going to be useful if you could do it this way if you need it. So I'm going to go to Summary Stats, Correlation, and I want to know what the correlation coefficient is between the MRI and the IQ scores. So, and then if I scroll down to the bottom of this pop-up window, it has underneath this graph option that I'm going to show this, this thing here. I'm going to uncheck it and I'm going to hit Compute. So what I found out then is that the correlation coefficient for between MRI and IQ scores is 0.647. Now, from that information, so if I know what the correlation coefficient is, from that information, I can compare the correlation coefficient to the critical value, just like we did in Chapter 7, to determine if there is a linear, to determine if there is in fact, a linear relation that exists. And so you are evaluating whether or not your correlation coefficient is greater than your critical value. If it is, then there is a relation, and if it's not, then there isn't a relation. Now, what if I wanted to take that scatter plot, and from the scatter plot of this data, I wanted to identify males versus females? So we can do that using the same scatter plot graph. I'm going to start over though, and I go scatter plot, Again, I'm looking at MRIs for the total data input, IQ scores for total output, but I'm going to group it by gender, which I didn't add a column, so let me start over here. So I want to group this by gender. So I'm going to insert another column over here called gender, and I need to identify which of these data sets we have here, which ones are for females and which ones are for males. So I know when I copied this over, IQ scores from 133 down to 132 were all represented for females, and then the remaining data that was entered was all males. So I'm going to identify them as males and females. Now, if I want to make a scatter plot of the MRI and IQ scores, so MRI, IQ scores, but I want to group them by their gender, and I'm not going to change anything else that was on here. When I hit compute this time, you'll notice that this is the same shape. It's telling me the same thing I saw just a moment ago, but now all of the dots that are on here can be divided into either blue dots representing female input or red dots representing male data, I should say. So now if I wanted to identify from this scatter plot which ones of them represented males, which one of them represented females, I could do that there. And then finally, I might be asked, what is the correlation coefficient then for only females? And what is the correlation coefficient for only males? So we've already seen how to do it if we wanted to just talk about all the data in total, but what can I do for just females and what can I do for just males? So we're going to go back to that stat, summary stats, correlation. And I want to know the correlation on the MRI and IQs, but again, I'm going to group it now by gender. I'm going to uncheck this option under the graph, hit compute, and you can see that the correlation for MRI and IQ for females is given at 0.542, and the correlation for males is 0.428. So an alternate way for us to not only look at a scatter plot, but look at the R value or the correlation coefficient would be using the scatter plot function just to see the graph, and then going back and using summary stats correlation to look at only the R value correlation coefficient. And this is helpful when I need to kind of subdivide things out.